circuit. In your physics helper, it tells you how to calculate the resistance for a parallel circuit. And so, all you have to do is take the inverse of each resistor and add it together. And in this case, it was 16/10. But that is not your final answer, because you have to take that answer and then take the inverse of that. So in the end, you get 10/16, which I think in decimal, I like to write them in decimal form just because it's easy to compare and contrast. Is it 0.6, right?
Yeah.
0.6, and don't forget your unit, because remember, you get points for the unit also, is ohms. So, parallel is the hardest one to calculate. It is 1 over each resistance. Take the sum of all those resistance inverses, and then take the inverse of your answer. B, we got, oh wait. Did I get this one wrong? What was the decimal for this one? I wrote it down somewhere. Where is it? Is it 1.6?
625. That's right.
Oh, that is right. Okay.
I think B.
Okay, yeah. So this one, we take the same thing, except it's just 1/10 and 1/2. Here, I end up with 0.6. But remember, we still have to take the inverse of it, right? So I need to actually do 1/0.6. And what's 1/0.6? What did you guys get when you took the inverse of your answer? It was 1.67 or 1.67 ohms. This group did the current calculation, so we'll get into that next. But all we want right now is the resistance. This one is, I want you to look at C. Actually, you can't see C very well. Yeah, I'm just going to move this down for a moment. C, the calculation that this group did was a parallel calculation. But is C a parallel circuit? It is actually a series circuit. It's just one loop with one resistor. So, in the end, all you had to do is just take the resistance. You didn't have to do the inverse or anything like that. You got the same answer regardless, but it's just 10. And then this group calculated their current, so we'll talk about current later. All right. We're getting into series circuits now. The calculation for this is just the sum, no inverses, no fractions. You add R1 and R2 together to get 12, and then R1, R2, R3 to get 13. So our ranking is going to be B, D, C, right? B, A. I can't do the alphabet backwards very well. So it's basically starting from your high resistance in series to your low resistance in parallel. Question? Definitely. Definitely. So I didn't ask you in this format to calculate the current, but let's go over that because even though I didn't ask you to calculate it, it is going to be on your quiz. So this is for my resistance. Conceptually, without calculation, what would be the ranking for current if I know that the ranking for resistance is E going backwards down to A? Kaya. Good. It's the inverse. So this is the concept that we learned in our in our Ohm's law lab, that current is inversely proportional to resistance. As one goes up, the other goes down. And so if E is the highest resistance, it's going to have the lowest current. All right, let's actually walk through the calculation for this. I had group B show the calculation for the current just at that specific resistor. And for parallel circuits, this one is for B. For parallel circuits, your physics helper tells you that the voltage of your battery, 3 volts, is going to be the same all throughout each resistor. So, according to your VIR chart, if you wanted the current through your resistance, your total voltage and your total resistance, this one should be 1.67, right? Would give you your actual current. So whatever this value would be. It is V divided by 1.7?
So it's going to be 1.8.
1.8. So that's the total current. Now, I'll answer your question in a second. If the total current coming out of B is 1.8 amps, is the current through resistor 1 and through resistor 2 going to be 1.8 amps? Definitely not. So in order to calculate that, you're going to have to use, again, current equals V over R, and you're going to have to use your total voltage and then take the value of each resistor. So 3 over 10, 3 over 2, 3 over 1, whichever resistor you're looking at, and then calculate each individual current for a parallel circuit only. So voltage stays the same.
Yeah.
You wanted me to calculate it?
For the parallel, you take the inverse or just the resistance?
For the current, you're not doing any inverses.
But for a parallel, you do inverse and just add them up to get resistance, the total.
Yes, but then whenever you get your answer, you have to take the inverse of that.
Can you show how to?
Sure. So if we want to get the current through resistor 1 was a resistance of 10. Let's see if I can get this up there. Of course, I'll never be able to get it down. My total voltage stays the same through parallel. Volts are the same. So it's going to be 3 volts over 10. And then this one has a resistance of 2. So it's going to be 3 volts over 2 ohms. And then you just do that calculation on your calculator.
Because the thing says 1.5 volts, is that because it has 2 batteries?
Exactly. So these symbols represent a long short represents one battery. And one battery, and if you have multiple long and short lines, that means the batteries are lined up in series.
So that'd be 3.
3 volts. 3 volts total. So knowing that symbol is something that you're probably going to see in your review worksheet. And I'm probably going to emphasize what that value is on the test, but you still want to be familiar with it. To find the voltage drop, it would only be relevant for series circuits.
But how do you do that?
So first of all, your voltage drop is I times R. So you have, in this case, you have your resistance value. This is 10 ohms. And your current, so current in a series stays the same. So you have to calculate your current first. And in order to do that, you have your total voltage. So current total is total voltage over total resistance.
So you just add up 10 plus like 5 plus 2.
Yeah, so let's do it. We get 13, right? 13 ohms for the total resistance here. The total voltage is 3, so it doesn't give us a great number. Let's calculate it. Can someone calculate it real quick? I don't have my calculator on.
0.2.
0.23. And if that current is, let me use a different color. If that current is coming out of this circuit, out of the battery and into the battery, it's going to be 0.23 amps all around. And that's a property of series circuits.
But then in order to find the drop, you would just take like, if it's asking for the drop after R1,
Okay,
or like where,
sure. So
then you would just
first,
take R1, or would you take R2?
First, let's try to find the voltage drop through R1. So just how much voltage that resistor uses. 10 times 0.23 is going to be 2.3 volts.
And now no voltage drop there.
So that's your voltage drop.